Hello and welcome back. My name is Corey and you're my rubber ducks. And this is the series where we are creating a programming language from scratch. The programming language is named Tang. It means template language, Tang. And anyway, it is designed to be a library that you could include in another project. And we are using it using modern-ish, where appropriate, C++, tools such as Bison, Flex, Google Test, ICU, things like that. Vim is our editor, and we code in a terminal window. Why? Because I want to, because it's fun. And the goal of this series is to let you see I consider myself a decent programmer. I'm not going to say that I'm the best programmer in the world, but I'm also not the shabbiest either. But what I'm not is I'm not an expert in C++. I haven't actively programmed in it in quite a while. I taught beginner classes in it, but you don't get into any of the advanced or edge cases in that case. So yeah, this is as much for me to learn about C++ as it is for the fun of developing a language, because I've got a project in mind for it. But anyway, that's another thing. All right, so where are we? In the last 3 episodes, we have been doing so much work with functions, getting functions to work. And why? Because they're a complicated construct. And what the goal is right now is we want to finish that. That is, do as much more as we can. There's a few things that we want to accomplish, but most important is I don't want to do a 3.5-hour video again. I've spent a lot of time on this. I want to try to get this wrapped up rather quickly. Having said that, let's jump in. We're going to try to see if we can implement return statements, and there's 1 or 2 other things that we need to do along the way that just fixes some problems. So as I say, there's nothing up my sleeves. I have not pre-prepared anything. If I say git log, the last commit that we did was the end of episode 38. This is episode 39, of course. And if I say git show, it says, why is there something different? Oh, git show is the last one. I meant git status. Corey just forgot all of his git commands. It happens. Git status. Git show is the last log message, and I was like, but that's editing. I mean, that's changing the documentation. That was the last commit that I did, was to update the documentation. All right. Well, let's jump in. We want to... One of the changes that we needed, and I'm on the right-hand side, I'm going to go ahead and say make clean and make test dash watch. All right, so it's doing a clean compile, and then it will watch for our changes. What I wanted was, when we call a function, what if we call a function with a different number of parameters than was declared? We're not testing for that. And so let's vim test, and I know that we're going to have to, because we're going to write a test case for it. And let's do... Which one? Source, program, execute. There we go. Okay, so our tests. This test is recursion. This test is just working with compiled functions. Let's do a new test then. Let's steal this part of that. That should not be there. And of course, since I yanked that, it All right, so what is our test going to look like? We want just clear it all out. And it's going to be function A that requires I was going to say a B and a C. Sure. And it doesn't do anything. And then if I call A with nothing, I should get an error. That's the goal. That's what we want. And we're doing that as a... should be get result. And it should be... an error. All right. Now, unfortunately, I have to answer a phone call, so I'm going to pause the recording. Okay, I'm back. And yes, that was a phone call. Had to take family, so pause the recording for just a moment. Where were we? Okay, so we're adding a function to test, and here we've got this function AB, or A, that takes arguments B and C, but we're only calling it with none. Sure. Actually, let's call it with 1. That way there's at least something on the stack. And it should... oh, yeah. Function call. Why not? I was saying we're expecting an error, and... oh, yeah, of course, that... segmentation fault. Good. Because we're not checking for the right number of arguments. So let's go to where we invoke call func right here. And we're saying call the function. So we're doing a static cast. And I think... first, right here is where we need to say verify that the correct number of arguments has been passed. How about that? Now, how do we know what that is? If we've already got args, if argc does not equal func conv dot get argc, I believe that's what I wrote. Do I have my documentation up here? I was looking around here earlier. Yeah, I do have get argc. Great. I wrote that. Okay. If it doesn't match, then we need to I don't know if this is the right thing. If this is the right way to say it. Verify that the correct number of arguments... well, yeah, we can. Okay. Incorrect number of arguments passed. Clear the arguments from the stack. So to do that, we'll say for what type is that? Equals 0. I is less than argc ++ I. Yeah, that's right. And all we're going to do is stack.pop back, and then push an error onto the stack. So we're going to stack.push back garbage collected, make computed expression error. Can I just pass in a string? I don't remember. We're about to find out. Supplied. Function call. And then break. See if that compiles. Computed expression error only takes an error, so that's simple enough. Just go error. So argc oh, that's just an int. The other way around. There we go. So we still have a segmentation fault. Oh, and the part of the reason may be because I haven't. I'm. So the easy thing to check would be the cout of p1.dump bytecode. Okay, so we do have bytecode, and let's just see what it says. Null val to for the A, jump to 6. Six is a function 2, 3, so the argc is 2, and 3 is the thing. Poke 0, so put that in stack position 0, and then pop it off. Okay, that's fine. Integer 1, peek 0, call func1. Now the question is where is it dying? We can do that by going to the top and oh, I'm not executing it anymore. Do you see the error? I should have called execute.getResult. Some days. Some days. Function call an unrecognized type. Now that does surprise me, but we can fix that in just a moment. It's calling, okay, so it does 0, 1, 6, 9, 11, 12, 14, 16. Oh, call func, and then the reason it doesn't move on is because I can remove that, and now call func. Here we are. Because before I break, I need to set PC plus equals 2. So that it will keep on. It was trying, I didn't move the PC, so it just tried to execute it again. And there we go. So, it is correct, and we need this to be incorrect number of arguments supplied at function call. All the tests are passing. Make this a commit, and we check that number of args passed match number expected. I don't have to push this yet, but I am. It's just common. Okay. Now, what do we want to do? We want return statements. So I can already tell you we're going to have to add something to our AST. So let's edit our make file, and we need an AST for return. So, resume. Oh, wait. We already have an AST for node return. Never mind. Yay. Okay. So vim our include. We are going to need test. Our include of AST node return our source for. Oh, before we do this, there's something I want to change. Okay, so vim source slash AST node. So everything in AST node. And let's do just the parent AST node, which is, yeah, number 6. So this is a small refactor. And you see how we have the collect identifiers, collect strings, collect function declarations? I don't want all of these to be separate. We are going to, rather, instead of collect identifiers, we're just going to call this compile preprocess. Yeah, compile preprocess. Now, why am I putting it like this? Well, oh, am I in the? I'm in the sources. I'm not in the includes. Oh well, got to do it here as well. Basically, if I delete those, they didn't have anything in them, right? So that was the right thing. I want to compile preprocess. That's what I want. Okay. So vim include astnode.hpp. This is going to be compile pre-process, and this is going to run any pre-process analysis needed before compilation. And now delete those. So we've got just now compile preprocess. We do this now, everything's going to complain because it's like, hey, this doesn't, we don't know what to do with that. So I did. Did I not? I guess I didn't delete these. And that should be compile preprocess. So there we go. Still going to complain. It doesn't know what to do with all those. That's fine. We're about to fix this. So we're going to include AST node, all of them. And we'll just start off here. Compile preprocess. And that one's going away. And so this is a slight bit of refactoring. And how are we doing this? Okay, so I've already done that one. Instead of node if else, there we go. This doesn't have one. Okay. This does. And we're going to next go through and move those all into the same. Why are we doing this? Because we're about to have to use this exact same pre-process idea. We've used it to collect the identifiers. We used it to collect the strings. And I think we're going to need it in a little bit. We may not need it for the return. No, we don't. That's for something else. But oh well. This has got to happen as well. So, okay, maybe it will be a longer video than I intended. I'm sorry. I started doing it and say, Corey, you could undo it. Yeah, but now I've already started it and it's going to be on my mind for the rest of the night if I don't do it. And now it's nagging me in the back of my mind that I started doing this. That one doesn't have one. That one doesn't have one. That one doesn't. Okay, so we're clear of all that. Now it's saying you don't have the declaration in the sources. We're about to change that. Source astnode.star. And for this one, we are going to %s. We're just going to change collect identifiers to compile pre-process, and we're going to do that globally. There. And now that's all that had to happen because we're just passing it through. Okay, so now this is the AST node. Already did that one. For this one this one again is a pass through. That means we can get rid of that one entirely. This one doesn't have a compile preprocess. This one it does, and so we can do this with the this is the same thing. And by the way, when I was writing this, writing the collect strings, it was in the back of my mind, I shouldn't be just copying and pasting. I should have designed this better. So this one, does it have... Okay, so this one... The collect identifiers is now called compile preprocess, but notice we're not calling that on any of the child things. We're actually doing something. And the same way here. So now we just combine those three. And that's correct. That's right, and we don't have anything else there. Okay. hey, this commit's going to be a net loss of lines. I like that. And it's technically, it's faster because we're not running through multiple preprocess collections. So this doesn't have a compile preprocess. It only has collect strings, but we can change that to compile preprocess. All right. Now the ternary is definitely going to have it. So yeah, all of these were just copies, and that is never the way to go. Part of it is I'm doing it on screen in front of you, and I just have to make a decision and go with it. Otherwise, I do what happened last time, and I just stare at my screen for a long time and don't talk. And that's not very exciting for you. So sometimes that means I make mistakes because I'm not thinking through it. I wouldn't have made this same mistake if I were not talking while doing it. I say, Corey, are you blaming us? Yes. So the node cast is not doing the pre-process. It should. So we'll have to add that in. And we'll just yank this one. Well, that was a Boolean. Well, the cast, there we go. The cast should have one of these. And it needs it on its expression. Yes, that's right. And it's probably going to complain that... hadn't complained yet. It will. It'll complain that I've defined something that... or I've defined a method that's not been declared. Yeah. Node block. So now, what's it complaining about? Source ast node block.cpp. Oh, well, that should have gone away. That's why. Is that right? Yeah, there wasn't anything else. And there it is, the binary. Wait, no, binary. Oh, no, wait. AST node cast. When I copied and pasted, yeah. I didn't change that. AST node cast. And now it's not going to like it because no declaration matches it. That's fine. So I can vim the include AST node binary include AST node cast. Why? well, the binary, just so I can yank the declaration and this so that I can everything should still work. All of our tests should pass. Okay, program.cpp. I can live with that. So our source program.cpp, and now this should be, instead of gather the identifiers, let's do is that a problem? I think that just needs to happen first. There we go. Everything should work. Everything passes. Yay! Love unit tests. Okay, so bunch of changes. Just making sure that everything is what I'm expecting it to be. And the answer is yes, it is. Okay, so git commit, and we're going to say single pass. There we go. 65 insertions, but 172 deletions. That's better. Simplify our code, have the same functionality. Now the return. So if we look at the source, AST node return, and the include AST node return, I know I'm doing them in the reverse order, but that's fine. Let's edit all right, sorry, that was a work message that came across. Not doxy file, but we're going to edit flex, and we're going to edit bison. Now, first of all, what do we need in flex? We need a return statement, and I don't think that we have one. No, oh, all these are returns. Oh, wait, we do. Okay, so we've already added it. Let's see what we've got in bison. Do we have the return here? We've already got the token added. Okay, so we've only got return and an expression, let's add to this a return and nothing. And that's as simple as a make shared an AST node return, and we've got to give it an expression. We don't have one, so we're going to standard make shared AST node, which is just a null. Comma at 1 and there. Okay, so we should recognize a return. We just don't know what to do when we get to a return because we haven't written the compile for it. And here is the problem. What does a return basically do? It's going to put something on the stack, right? And it's going to jump to the end of the function. The problem is we're in the middle of compiling the function. We don't know where we don't know where we can jump to yet. So this is a problem that we're going to have not only with returns, but with continues and with breaks. And we haven't solved that for any of them. Basically, it's something that's being compiled in the middle, and you've got to put the opcode, but now you need to update that. So, you know what, let's just go. So a return semicolon or return expression is going to make an AST node return. That's fine. I'm going to write that. It doesn't know what an AST node is. How can it not? Tang AST node. Or am I just assuming that it doesn't know? AST node return. You know what? I have documentation that exists. Let's look at the class. Our AST node return a shared pointer to an expression, or a shared pointer to an AST node, and a location. That's pretty much what I expect is happening here. Okay, let's see. This is just going to be a stupid mistake that I'm making, I know. Line 164. Oh wait, that's different. Yes, I'm skipping through error messages, and that may be the problem, is that I'm looking through them too quickly. But I'm like, the problem is not going to be somewhere in user include C++ 11 bits alloc traits.h. And so I'm looking for something that makes sense. And, well, it's included here. And well, Bison, that's where I'm editing. So that's where I'm expecting the problem to be. But line 164 is include tangscanner.hpp. So there we go. Tang scanner. Okay, 164. 311. Okay. 311. What's that? 311. Doesn't like this. I'm probably just making a stupid mistake. Of course, the problem is I have to provide it with a location. Yeah. So we can at least have an empty return statement or just a return. But now what do we do about the compile? So edit source program. Are we doing the dump? No. I need to worry about the compile. So that is going to be here. So what do we do? When we get to compile, we do not... Ooh, do we? Is it as simple as calling the return? Let's write a test. True, false, false, true. Should not give us an error. Let's just see what happens. It should give us 1221, but it's giving us a null. Okay. Oh, but it's because that's the result. I'm not getting the output of it. Get result dot out. Not get result dot out. That's gonna. What do you not like about this? This usually means it doesn't know how to compare the left-hand side and right-hand side. Which, yeah, that's what I'm getting. So let's go to the very, very top. Operator equal. Types are a character and an error. Okay, yeah. Duh. I mean, I said a character, but I meant a string. 1221. It did it. Evidently, now, here's the problem. I didn't think it would work what I wrote before. And now I want to verify why it does. And this is just for my own knowledge. It's like something's... Yeah. So we're going to p1.dump bytecode. There we go. Oh, wow, that's a lot. No, I mean, it makes sense. I'm calling the function 4 times at the bottom. So null val, that is going to be A, the name of our function, because that's the only value that's there. Okay, jump to 17. So our function is between 3 and 17. Now, I'm just going to point it out that it pokes in and 0 pops, puts a Boolean true on the stack, peak 0, call function with 1. And then its result we print, and then pop the result of print. Fine. Do it again, false, the function, call it, print it, pop it. That's why you see this. True, false, false, true. And that is mimicking what I'm doing here. A couple of reasons I did it this way. First of all, I wanted to test both paths. And second, I wanted to make sure it could be called more than once in a row. So now let's look at what's happening in the function itself. I'm calling so peak 0, that loads in the value condition. I didn't have to reserve any places on the stack for identifiers or strings. So I'm jumping a false to 11, which puts a 2 on the stack and says return. And there was one thing passed in. Okay. If it's not false, integer 1 on the stack and jump to 13, which is also returned because we return. That's saying return. And then what is this other return that you can't get to? That is the end of the function, in case maybe the return was inside an if statement. So that's the next thing we need to test. So this looks correct. And okay, I'll tell you one of the reasons I'm surprised that this worked. It's because the other 2 times I've written this, I did returns completely different. Now the continues and the breaks are going to need more processing. But if this kind of just works, well, I'll be happy for a shorter video, and you will be too. But okay, so let's do a number 2, shall we? Give ourselves some room, and this is going to be P2. There we go. And if condition return, what did I do earlier? I'll do 1. Sure. I want to see what this does. I mean, I'm pretty sure it should just be a 1-1. The output was 1-1. Okay. Let's see what the code looks like. So jump to 17. That means we are in between 3 and 17 again. 3 is peak. That's a condition. Jump if false to 11. 11. Wait. Oh. I was like, there is no number 2 in this one because I forgot to replace that. There we go. Okay, jump to 14. So the function is between 3 and 14. Or 3 to 12. So 3 is peak the condition. Jump if false to 11. So if it's false, it puts a null value on it and returns that. And we don't print a null. Okay. If it's not false, put an integer 1 on it and return. It's correct. It's working. And part of the reason is because one of the things I enforced from the beginning was our statements must always everything must leave something on the stack, and the statement must pop it. And so I can put a return anywhere and just tell it how many things to clean up. And that's the number of items that are on the stack, which are your identifiers and your strings. That's it. Yeah. Should write a few more tests. Actually, do we need to? Because we showed that it works as a single statement. We showed that it works when it just reaches the end of the... Sorry, I just hit my mic. We showed that it works when the function reaches the end of the function and it returns a value, or when it hits return in the middle. I want to do one more. Actually, yeah, one more. Don't think I need to dump it. But all that I'm going to do is, instead of exiting immediately, I'm going to print high. And that should give us a 1 high high 2. 1 high high, oh sorry, 1 high high 1. And that's correct. Oh, by the way, this should have been changed to 1, 1, and this should be high, high. And again, just making sure that something is actually executing after it. That's it. Returns are working. So I guess they were kind of working before. I just hadn't tested them, and we ended up doing a refactor of other stuff. So maybe the title isn't correct. I'm sorry, I put the title on. The title is what I intend to do. But now we verified it. Yeah, I did it. Okay. Let's see what I've got different. So, oh yeah, we did add a return with nothing. We don't have a test for that. We need to do that. A return with nothing. So this should give us nothing, high, high. Well, high and then high. If that passes, we're good to go. It does, and just to prove it, here I'll change this. Yeah. So that's right. And we proved that a return statement with nothing else in there works. Once more. That's it. Well, now we got to refresh our docs. And we're probably going to have some missing files in this because I refactored some stuff. Yeah, well, there's new files untracked. And I'm just curious, are there any? These are all modified, modified, modified. Deleted, yeah, there's a few deleted. So, did it catch them all? Yep, it does. I don't think it used to do that. I think if you said git add, it would only do the new ones. Oh well. Update docs for episode... What episode are we on? You know I never remember. Episode 39. And it is live. All right, so I want to check out something. I want to say quite literally, check out episode.038. Well, it's going to recompile it. But just so I can say, make clock to see where we were. I'll let the compile finish. That's fine. Git checkout master and make clock. Yeah, we ended up with less lines total, even though we added tests and an empty statement. But hey, that's good. Now, are there more things that we could do to the function? Yes, we could add support for, trying to think. There might be some modifications. Oh, well, we know that there's the other two types of functions that we need to add, and that's coming. Native functions, like library functions, and bound functions, but we'll worry about that later. Next, I don't know, there's so many things. Should we look at arrays? Should we delve more into strings? Strings are going to take a lot of work. If we do arrays, that could give us some interesting stuff. If we go into arrays, then we start getting into indexing and slicing, and that's some pretty handy stuff. But whatever we do, they're usually bigger. So this one, thankfully, was a lightweight one, and I think that we will then just end on a high note with a shorter than normal video here. So, once again, thank you for joining me. Hope it's been, I don't know if I want to say fun, entertaining, enlightening, or maybe just background noise. I don't know. But hopefully someone gets to enjoy this or benefit from it at some point in the future. As always, thank you. Have a great day. Bye.